Well, ladies and gentlemen, thank you all for coming. Last lecture. Here's the plan. We have some guests, and they're going to talk to you about what they're doing in data science and how you can be involved in their classes. And then we have some other guests whom you know very well, who I'm not quite sure what we're going to do with them, but we'll figure something out. And then I'm going to spend a few minutes talking about if you want to go deeper into data science, what are your roots in math, stat, and CS? And hopefully we don't spend the whole session doing that, because then I want to give a big picture top-down of the class, talk you through the first 3 of those 5 top-down sections that are in my mind, show you where they are in the textbook, and then on Monday and Wednesday do sections 4 and 5, where I think is the heart of what we've done. Does that sound like a plan? Sounds like a plan? Yeah, well, I mean, you're kind of a captive audience, so there's not much you can do if you don't like it, but I think it's a plan. All right. The first person that I would like to introduce is Professor Elizabeth Purdom, and she will introduce herself after that.
Great. Hello. So yes, I'm a professor in statistics, and I work on applied statistics and data science areas in the area of biology, just so you know who I am. And why I'm here is I'm going to talk to you about a new course that we're offering for the first time next spring. The number is Stat 28, and it's called Statistical Methods for Data Science. And it's a new course, and the goal of the course is precisely to follow up on this course. And the topics, or the goal of the course, is sort of a broad survey through picking up where you leave off in this course, a broad survey through a bunch of additional, more higher-level methods that you haven't gotten to. This course, of course, lays a foundation for both computation and ideas about inference and hypothesis testing and so forth. And so our goal is to have a follow-up course for people who want to keep going, so that you have a lot more tools at your disposal when you come across different types of data and go beyond the basic foundations you've learned here. And I know a lot of people have questions about different options for what courses they can take, for those of you who are interested in going on, and what kind of course it'll be. So this course, Stat 28, has no other prerequisites than this class, Data Science 8. So you're all qualified. We don't require calculus, but we do expect comfort at a pre-calculus level. We do use math and equations, but we're not explicitly requiring calculus. So the goal is to make it very open to sort of everyone who takes Data Science 8 can go on if they want to, and it doesn't add a lot of additional trajectories. So some people who might be interested are people who aren't going to eventually major in something like computer science or statistics or a data science major, but want to learn more in their area of biology or social science or whatever they're going to go on and do. Or people who just really enjoyed this course and want to keep going, and they want to sort of prepare themselves for those kind of data science majors and get more of a taste of what sort of higher level techniques look like. So it's a broad survey. It will not have as much. We will be using computation and the skills you used here, but we won't be doing quite as much of the computing side of things, and we'll be more focusing on the data analysis, statistical side of things. So that's just to help you kind of piece out how it compares to other courses. If anyone's interested, I can talk specifically about what we're talking about, but I'm presuming since you're in this class, it won't mean a lot to you since we're going to teach it next time. But we're going to move on and talk about data sets where you have larger number of variables, and how do you put them together, and how do you ask a lot of different questions of the same data, and just to move on a lot of additional visualization techniques as well. And all of this will be very data intensive in the sense that it will be like Data 8. You'll have labs where you do it, where you learn how to do the actual manipulation in the labs. You'll have some small assignments with data as well as regular homeworks and so forth. So it's very much following on sort of the same kind of model for the Data Science 8. Does anyone have any questions? And the size of the class is much smaller than this one. We're not expecting, it'll be more on the lines of 60 people in the class. So it's a bit more intimate, but there's plenty of space in the class for people who are interested in signing up for it. Does anyone have any questions? Yes? So we are actually, thank you, I didn't mention that. We're actually going to use R, but we know everyone in here is using Python, so we're going to transition people into R. It's not something you're expected to know going in. And the reason we chose another language was because once you learn one language, it's frankly not that hard to switch. And two, R is the language of a lot of statistics, and there's a lot of things in there. It's a very, very common language, like Python, to be analyzing data. So we think it's a great skill to learn regardless. And it's where a lot of, on the statistics side of things, all the kind of new things, a lot of them get published, if you like, in R. So it's a useful skill. Yeah. But we are intentionally, especially at the beginning, going to use a very similar environment and sort of move you into the R environment. So we're hoping that it would be just sort of, learning slightly different syntax, but basically it's the same ideas. Yeah. Are there any other questions? Great. Do you want to introduce first?
Thank you very much. Appreciate it. Right. Highly recommended. It's going to be a fun class. And as Professor Purdom said, no further prereqs, just go in and analyze perhaps larger and more interesting data sets. So the next person who's going to talk to you is somebody who, actually is very familiar to some of you because he's their GSI and has been a partner in developing Data 8 since 2 summers ago. So this class exists and runs, you see me a lot, but it exists and runs in great part because of Henry Milner, who is going to talk to you about the next class for whom he's going to perform the same service.
I can't figure out how to get it in presenter view.
Oh?
It's like...
What are you using?
Google Docs. Or Slides, rather.
Google Slides has a...
It just, I lost the top half of the screen, so I can't click presenter. It's like this.
You got it?
Yeah.
Here.
And now it doesn't know that it's...
Can I use my machine?
I think it's a machine thing. Well, whatever.
You want to take that thing off? I can tell you what I do. All right. So...
That's okay. I don't really need slides.
Hang on a second. You have them. Okay. So what
I'll just do it
are these just Google Slides?
Yeah.
So
but it's fine. I'll do it that way.
Okay. Show them the slides.
Yeah, but then you'll see my speaker notes. It'll be all embarrassing.
Oh, I see.
Yeah, but I need them because I don't know what I'm going to say.
Sorry, this is how staff meetings always go. We can't get the technology to work, and somebody's always laughing at somebody else. I'm sorry, we've just gone into staff
Well, okay,
meeting mode.
just ignore the bottom half of the screen because otherwise it's going to be really weird. You're going to know what I'm about to say. But I do want to show you this picture.
Use the mic.
Hi, I'm Henry. I'm a TA for this class and also going to be TAing for Data Science 100, which is a new class that's being offered next semester. It's kind of similar to Stat 28, I guess, in that it's sort of a next course after Data 8, but with a slightly different emphasis, I think. So the people who are teaching it are going to be these 4 people who are sort of all amazing data scientists or statisticians or computer scientists. And in addition to me, 2 other TAs from this class, Sam and Joseph, are going to be TAing. So Data Science 100, you should think of it as a bridge to sort of all of the other upper div data science-y courses that are offered here. So on the left, you see what it's a bridge from, and it actually has some extra prerequisites in addition to this class. So unlike Stat 28, I guess, it's going to require an intro programming course, so either 61A or the connector course CS88, which I know some of you are taking, or Engineering 7. And it's also going to use a little bit of linear algebra, so it's going to require either Math 54 or E16A. So it has some additional prerequisites. So it's intended, really, if you want to get to these other upper division data science type courses. Right, and it's for the first offering next semester, it's going to be limited to 100 students. The enrollment just opened up a couple days ago, I think. So if you want to enroll, then you should enroll. I think there's going to be some sort of randomized scheme for getting people into the class. So you should still enroll if you want to be in the class. Okay, so what can you expect to get out of this class? So I want to say sort of what I guess I want to summarize or put in context what you've learned in this class. Because DS100 sort of focuses on this entire, what we're calling the data science life cycle. So there's these 4 steps that you take when you're trying to answer a question about the world. And the thing is, you've already seen each of these steps in this class. Like you've already done a tremendous amount of work on each of these things. So for example, you start by defining a question that you can answer with data. And you've seen hypothesis testing, where you define a null hypothesis that you can test using data. And you've also thought about population parameters that you could try to estimate, like the proportion of some kind of voter in some population. Right? It's defining a question that you can answer with data. The next step after that is finding some data that you can use and getting into a form that you can use. And for that, you've taken maybe the biggest step of all, which is learning a programming language. And you've also learned how to work with data that are in tables. So those are some huge steps. Then you sort of have to understand what your data look like. And for that, you've seen a bunch of statistics that you can compute about data. You've also seen a bunch of visualizations like maps, plots, histograms, and things like regression lines that tell you the relationship between two things, that sort of tell you what your data actually look like. And then you want to actually answer your question. And for that, you've seen a bunch of methods, like estimating a population parameter, computing a confidence interval around that estimate, actually running a hypothesis test, predicting one thing from another, classifying something as one category or another. So these are all ways of understanding the world. So these are all things that you've already done. The thing is, when you actually have a question that you want to answer about the world, it's probably going to be a little bit more messy than anything that you've seen in this class. Because the examples that we pick in this class are designed to sort of illustrate one particular part of this life cycle. When you actually have a question that you think is really important, it's probably going to be harder than that. You'll need to be able to integrate all these things together, and you'll need probably more tools to sort of deal with the complexities of real-world questions. So sort of providing you those additional tools, building on the foundation that you already have from this class, that's really the goal of Data Science 100. So I just want to end with maybe 2 examples of that from Project 3. So in Project 3, we handed you this table that had the word counts from a bunch of songs and the genres and some other metadata about them. When we prepared that data set for you, the staff, not me, but Singhao Pan from a year ago, had to do a bunch of work to get that into a usable form, where you could like run your k-nearest neighbors classifier and it would work okay, like you'd get a reasonable result. If you were to actually try to classify genres yourself, if you were really interested in that, then you'd have to do that work yourself, and that involves a bunch of tools that that you need to sort of develop for that. In particular, text analysis, and also maybe working with large data sets that need multiple machines to even work with efficiently. And then the actual classifier that you used in Project 3 was a k-nearest neighbors classifier. You probably found that it worked okay. You probably got around 70% accuracy. Maybe if you picked really good features, you got up to like 75 or 80%. I don't know if anybody got there. I think that was pretty hard. If you think about it, if you wanted, like, again, if you really cared about classifying song genres, then like 80% accuracy is probably not good enough to have a tool that you would actually want to use. You would probably want something that's closer to like 95 or 99% accuracy to really use it. And the same is true of many sort of problems that you'd want to use data for. You need more accuracy. And often that means that the first tool that you try is not sort of good enough. And k-nearest neighbors is good for some things, but it's not great for a lot of other data sets. There are sort of some sort of complex problems with it that we haven't had time to cover in this class. And there are like millions of other possible classification techniques that you could use. So it's important to sort of have that toolbox. In particular, in DS100, you'll learn about deep neural networks, which are sort of they're all the rage right now. They're being used, for example, at Facebook to tell you if you have a picture, who's that a picture of, to like recognize faces. All sorts of internet companies use these kinds of things to solve problems that you might have thought 10 years ago were not possible to solve, and that you couldn't really solve with a k-nearest neighbors classifier. I guess that's all that I want to say. So the website is ds100.org. If you're interested, check that out and sign up for the class. And if you have any questions, I think I should let Ani get to her lecture, so maybe ask me after, unless there's something quick now. Okay. Any questions? Yeah.
So we'd mainly be learning like Python and pandas and stuff like that.
Yeah, so it's the class is taught in Python, and you'll be using. So yes, sort of what language we'll be using. It'll be Python, and you'll be learning about a tables library that is not the data science library that we use in this class, but it's called Pandas. It's sort of the thing that people actually use in Python. It's a little bit less user-friendly, but it's sort of integrated with a lot more software packages that do interesting statistical stuff. Yes. Sorry. Oh, she asked, will we be checking the prereqs? And the answer is yes. Yeah. Yeah. Just linear algebra, I think. It's an interesting question. Yeah, no. So yes, this is calculus a prereq, and no, 54 is the only prereq. 54 or EE16A. Okay.
Thank you, Henry. I tell you what, it's great that he's here. Stay. Don't leave. You can't leave. Oh, you're sitting. Okay. He's sitting down there. Great. So you can sit, but I'm just going to make you stand again. So I walked into class today, and I expected to see Elizabeth, and I saw Elizabeth, and that was nice. And I expected to see Henry, and I saw Henry, and that was nice. And suddenly I see this crowd of other people, and whom I recognize. And I asked them, what are you doing here? And they said, well, we were kind of here, and it was kind of the last class, and we thought we'd show up. And that is basically emblematic of this class's staff. I didn't ask them to come. They're undergraduates like you. It's the last Friday of lectures. They've got stuff to do. They've got exams coming up. But it's the last day of Data 8, and, they thought they'd show up. Please give them a hand. Stand up, guys. This class 500 people working on a computing environment that we provide that's not on your own machines, with material that comes out week by week, this class would not run if it weren't for these people and 10 others, in fact, counting the tutors and lab assistants, a total of over 50 staff who devote themselves in this manner. The vast majority are undergraduates. I think we have 2 graduate students. Yes, out of the 50-something, only 2 are graduate students. Henry is one of them, Nishant Desai is the other. Everyone else is an undergrad, several of whom are sophomores. And so, your undergrads, you know how busy you are. They're busy too. But they take the time and they spend the time to make this class work. And and we all owe them a real debt. So thank you very much. And now what I want to do is quickly go through some of the some related questions that arise in, what am I going to do next? And I'm grateful to Henry for having given us actually a great review of what we did in Data 8. It was very, very helpful. But there were some things on his slides that I want to go through, and this always happens. Yes, there we go. All right, so that's what we're talking about. And so if you want to develop a little more methodology and work in a specific domain, you've got the connectors. Don't forget those. You can take any connector at any time. And you have Stat 28, which you just heard about. Which connectors? Look at data.berkeley.edu. That always has the connectors. That has the Spring connectors. I have heard a rumor that there might be a connector in the Spring on the data to do with the Japanese internment. I asked, can this professor please come and talk? It's not quite ready for prime time yet, but it might keep an eye on data.berkeley.edu, because in addition to what's announced now, apparently other very interesting things are in the works. Connectors. Now, I say most connectors because not all of them develop methodology or applications in a domain. There are a couple that go deeper into the math theory and the code, and they are Stat 88, 89A, and CS 88, which is having some very peculiar problem getting set up for registration for the Spring. I don't know. Has anybody been able to register for it? Yeah, there's something going on with instructor codes. We will sort that out. But what these do is if you have Data 8 and Stat 88, for example, you have satisfied the prereqs for Econ and Haas, but that's not why they were developed. They were developed because there are many people in this room who would like to know the mathematical basis for what is being said. And with a little bit of math background, like a semester of calculus, you can do quite a lot. Of course, you can't do all of it, but you can do quite a lot, and that's what happens in Stat 88. And in CS 88, correspondingly, there are many people in the room that would like to know a little bit more of, what can I do with this language? And there's always this feeling that, they're not quite telling me everything. We aren't, because we have a fixed amount of time. And so they go deeper into the CS, and that's something you can do. I think, Henry, am I correct in saying this? That Data 8 plus CS 88 satisfy the 61A requirement for entering 61B? Yes, somebody there knows. Okay, so 61A is the intro programming course, and 1,600 people took it this time. So I would like you to know that because of 61A, there is now a new unit of measurement for class enrollment. It is called the kilo student. They're at 1.6 kilo students. We're at a mere 0.5 kilo students, so we're quite intimate, really. But not everybody wants to take 61A, so Data 8 plus CS 88 is a way to get yourself enough that you can then do 61B without having to go through kilo students. Yes? You do not have to take them at the same time. Okay, so that's just, material roughly at this level, slightly deeper. Yes? Thank you. Okay, Stat 89A is being offered next semester. That I can answer. Will it count for Data Science 100? I do not know. But if you're taking it next semester, then it won't count. You have to, I think, have it before. I don't believe. Are these co-recs? These are prereqs. Yeah. So I don't actually, I do not know about 89A. That's a question we can ask. Thank you. Can you send me an email so I can actually answer you? All right. All right. So now, if you actually want to become a data scientist that is not just using data science in a domain of application, which is actually a wonderful and rich thing to do, but if you want to be able to develop more tools of data science, then don't keep looking for data science in the title. People come to me and say, what new data science courses are being offered? And my answer always is, have you taken all the old ones? Right, we have been teaching data science for years. And as you know, John Snow with cholera back in 1850 was doing data science. The only reason it feels new is somebody invented this term, 5 years ago, and now suddenly people think it's a new thing. But it's been around, and computer science and stat in Berkeley in particular have been doing it for a very long time. And so, if you are going to be a data scientist, you need some basic tools. And here are the basic tools. You need to know how to program. Right? So you need something at the level of 61A, and you now have two options. You probably need a little bit more, but at a basic level, you need this. Okay, now, you need linear algebra, and I want to be very clear that you have a good picture in your mind of what it is and why you need it. Imagine in your head a table of data, table of numerical data. Yes, do you see rows and columns? Yep. Now, those are your numbers, and anything you're doing is a numerical manipulation on such an object. That's what linear algebra teaches you how to do. Two-dimensional arrays, possibly three-dimensional arrays, how do you deal with those? What are properties of those? What can you do? What can't you do? And you can see, since you deal with tables every single day, you actually have to know the math of that. At least at a fundamental level, that is Math 54 and E16A. Math 110 takes you a little bit deeper and helps you understand some of the innards. Eventually, if you're going to be a data scientist who develops methodology, it would be a great idea for you to take Math 110. But if you want to be a data scientist who uses methods of data science, then I think the 54 and 16A should get you a long, long way. So there's computing. There is linear algebra, and there is calculus, because you do have to know something about minimizing and so on and so forth, about curves. Probabilities are areas under curves. You have to be able to use curves, surfaces, and some minimizing. So a start is 1A, 1B, and Math 10. That'll take you a long way. If you have Math 53, you can do somewhat more interesting stuff. So these are, I think, very basic tools for you to become a data scientist. Now, what I'm going to talk about, because of my background, is the next thing that you need to get going at all. You need to understand randomness. And from this course, you have a very clear sense of why you need to understand randomness. You also have a concrete sense of sampling variability. But you need to understand randomness because your data are coming in and you have models of randomness and you need to understand how they work. So there is probability and there's inference. And once and for all, I would like to make a perhaps crude but I think useful distinction between these two so that you know when somebody says probability, what are they saying, and when somebody says inference, what are they saying. And so probability asks the following question. I know the model. What can I say about the random events that are going to occur? Right? And maybe, I don't know the model completely, so whatever I say about the random events will be in terms of some unknown element in the model. But basically the thing is, I have the set of assumptions. That's what a model is. I have a set of assumptions about randomness. I'm predicting how the random events are going to come out. This is taught in Stat 134 or the new course that I'm teaching, Prob 140, which assumes this as well as assumes data 8 as well as calculus, so we'll be doing the math as well as Python, and it promises to be quite a lot of fun. Inference asks the reverse question. Inference starts with a sample. Here's the sample, and it tries to look back to what was in the model. Based on the sample, what can you say about what was in the model? Now, you got a sample, and you did have some assumptions, but those assumptions perhaps are not completely well formed. There are some gaps in them, and can you use that sample to fill in the gaps? Is something that inference asks. It also asks, okay, so if I have a model and I have this sample, can I use this to predict the next thing that will come along? And as you can see, that's kind of a hybrid between inference and probability theory. This is taught in Stat 135, which requires the probability basis. People ask about a data science major. By the way, you know what? I should address this question. A lot of people ask when, I've heard that it's going to be in 2017, or when is it going to be? Nobody knows. And I am as frustrated as anybody else because a lot of us have been working on this for quite some time. We will tell you as soon as we know. But the thing is, even without the label major, what we are telling you is what we think you ought to learn, and if there is a major, almost certainly these are the kinds of things that are going to be required. So that's the core. The math and computing and the probability and statistics, and what I'd like to do is I'd like to give you some sense of going deeper in the probability statistics direction and in the CS direction. But questions? Okay, we're talking about Data Science 100? Website says concurrently. Okay, thank you. What? Okay, so he got it from Joey Gonzalez yesterday. Maybe the website's going to change. They're working something out. But they're going to be very particular about how they choose students. For Prob 140, I actually went and checked everybody's prereq, and I threw out everybody who didn't have the prereq. It's still full with people who have the prereq. Okay. Data 8 prereq, yeah. Okay, so going deeper into data and stochastics, I had to give you that word. What does it mean? It means randomness. It just means probability, but it sounds oh so much cooler. It sounds cooler and it sounds harder, and so somehow, suddenly, for after centuries of having done probability, we're now all doing stochastics. Okay, great. We're doing stochastics. So what? You heard about in DS100, there's going to be some visualization, some scraping of data. Munging is this wonderful formal term for messing around with your data until you get it to a form that you can use it. And data analysis, when that's done entirely in R, that course is called Stat 133. Notice that it is not a prereq for 134. It is not even a prereq for 135. In 135, we teach R. I teach 135 regularly. And half the class has R and half the class doesn't, and in the end everybody turns up and is able to do whatever they need to do. Okay, so on Henry's slides there were the numbers of some statistics classes, and I was interested to note that they were exactly the same numbers that I have here except for 150. I have one more. And so the two upper division statistics classes that are heavily data analysis oriented are 151A, multiple regression, how do you pick variables to use in your regression and other related questions. And 154, machine learning, so classification, other learning techniques. And then there is the issue of, so we look at samples that are at a fixed time. Our samples are snapshots. At a fixed time, you got this set of people. But there are many fields in which you want to watch an evolution, right? Even for when you're doing machine learning, you have data that are coming in, right? And you're classifying and you're learning whether you're right and wrong, and then you're, the ones that you know are becoming part of your training set, and you have sort of this random process that evolves in time. It may also evolve in space. The probability of that, how does a random process behave, is the subject of stochastic processes, random processes. That's in Stat 150. The statistics of that, I'm watching a random process. What can I say about the underlying probability distributions? That's 153. And then there are questions about the stat core. Deeper into stat. And then CS is not my game, so I will simply tell you again, these are the same classes, many of the same classes that Henry had on his slide. 61B is a great thing to take. Lots of Python, Data Science 100, and machine learning. And then, any amount of other stuff that you could take. Left to me, I would take any class that has a title like Efficient Algorithms and Intractable Problems, though I think it's just known as Theory of CS or something, whatever. Okay, so that's a lot. Let me actually take questions about classes. How many? And I have exactly the amount of time I need to do the review that I'm going to do. But I do have time for a few questions. Yes?
So for those who have already taken Data 8, would you recommend doing CS88 instead of 61A?
For people who have taken Data 8, would I recommend doing CS88 instead of 61A? I think it really depends on the person. 61A is So I'm looking at this. There's a bunch of people who have taken 61A here. Let's ask them.
I don't think so. I think you should take 61A.
Okay. So people who have taken 61A and have done well enough that they are now UGSIs for this course, remember this is not a randomly selected group, say that you should take 61A. I say check out 61A. You'll really learn how to program. If you do CS88 along with Data 8, you will know how to program, not as in-depth as you will know 61A. But then if you can do just as well in 61B, who cares? So, in 61A, you will write an interpreter. For data science, you don't need to know how to write an interpreter. So that, it's a balance. Questions? Okay. So last slide on this topic. You cannot do all of this, right? You will die. Nobody can do all of this. You've got, 2 years, 3 years here left, right? You cannot do it all. Just pick some bits that you like, but if you are going to be a data scientist, it is very important that you pick a bit in each of the areas. Pick some math, pick some CS, pick some probability. If you just pick one of those areas, or if you say, I'm just going to do CS, you're not going to be a data scientist. If you say, I'm just going to do stat, you're not going to be a data scientist. If you say, I'm just going to do math, you're not going to be a data scientist. 2 of those is a little bit better, but really to be a data scientist, you need all 3. All right, so pick something in all 3, and then I think you will be just a fine data scientist. Just, make sure that you don't tell yourself, I need this and I need that and I need the other thing. I think Berkeley has very sensibly restricted the number of courses that you can take in a given semester, because people were taking 6 or 7 classes and then just walking around like zombies, not understanding why they were walking around like zombies. All right, so that is my spiel on life after Data 8. And I would like to quickly get to life almost at the end of Data 8. So questions about future classes? If not, I would like to move and talk about life after today. All right, plan for our week. Here we go. So it's day by day. Monday, I will show up here to lecture. Everything that I'm writing down is optional for you, of course. I will show up here to lecture, and I will review inference and something called mathy stuff, which I'll talk about in just a moment. Because those are the 2, I think, chunks of things that get examined other than, the programming and so on. So I will start on that. And I expect to have done, quite a bit of it, but not all by any means. Tuesday in the afternoon, I will have office hours in my office. Wednesday, I will come back to lecture, and I will complete those 2 sections to the extent that I can. And if there's time left over, we will talk about other things that you might want me to talk about. If you're coming to the reviews, please come with questions, right? I don't get this. Could you explain it? Because this is your moment. I will explain it. Just so you know, course capture ends today. So if you are not coming to the reviews and want to know what's going on, please ask somebody else. Because, okay, so I am going to discipline myself. I am very well aware that what I am reviewing is not just reviewing the course for the sake of reviewing, but also to prepare you for an exam, which is pretty early in the exam period. Therefore, I am not going to use Python on the notebooks. I'm going to use possibly the boards, which I haven't done for weeks. I maybe have forgotten how to do that. So a lot of stuff will happen that isn't actually captured electronically. So if if you're not coming, and one of your friends is, buy them dinner and make them tell you what happened. Okay, so that's Wednesday. That's what I'm going to be doing. But then there are lab times. Wednesday and Thursday, during all of the lab times, the GSIs and the other 10 or however many GSIs we have are going to lead review sessions that will work this way. So every lab session is, Wednesday they start 12 to 2, 2 to 4, 4 to 6, like that, right? So say the 12 to 2 lab session. The first hour, there will be a topic that will be reviewed. And they will do review problems. They will not reteach that topic. Don't go there to be taught it. There will be some, review problems on that topic and a little discussion. And the second hour is just going to be office hours. So anybody can come and ask any questions. And every single lab slot, so there are 3 slots on Wednesdays, 12, 2, and 4, right? And then 4 slots on Fridays, so that's 7 slots total. There's going to be some topic that's going to be reviewed, and then there's going to be office hours. Which topics? Watch Piazza. We're working on that. So we will post on Piazza this time, this slot, this room, this review. And you can pick which ones you come to, right? I think for the office hours, anybody can come to any office hours, yes? For the office hours, anybody can come to any office. So Wednesday and Thursday. Tuesday afternoon, I'm around. Wednesday and Thursday, the GSIs are around. And then there's Friday, and that's what's going to happen on Friday. Right? You are going to see Ferris Bueller or something where you are just going to not stress out. Okay? All right, that's the plan. Final exam. I sent a message around to you. It is at the RSF Field House Recreational Sports Facility. Please, please, please. The exam's at 8 in the morning, right? My experience with undergrads is that they don't function at 8 in the morning. They certainly don't function very well at 7:45. So if you don't know where the room is, you at 7:45 will not be at your best at finding it fast, right? So please find it earlier. And know where you're going to go at that hour. And I'm going to send a message around, and I'm going to ask you to come a little bit earlier so we can get settled and get going. All right. Bring something to write with, something to erase with. Water is fine. Do not bring your breakfast burrito. It bothers other people. All right? Please, 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 nothing that smells, nothing that is sloppy, and nothing that's going to spill, even your water bottle. Please. Out of courtesy to all. Now, after decades of having run exams with large groups of people, especially some exams at 8 o'clock in the morning, here is what I know. People come in, they start taking their exam, right? 500 people in the room. At 9:30, everybody wants to go to the bathroom. Why? Because that's when the coffee kicks in. Okay, so please, to the extent that you can take care of that kind of stuff before, that will be very much appreciated. Thank you. All right. We will provide you with a couple of reference sheets. We provided one for the midterm, yes? 2, Nishant? 2 for the final, as we did before. By the way, acknowledge this man. Nishant is the guy who makes those for you, based on Henry's stuff from previous semesters. So he will post on Piazza. I don't want to make claims for you.
Yeah, so try and have this out by the beginning of Dead Week, ideally Monday, so you have like a week before the final. It'll be posted on Piazza, and then we'll be providing those 2 pages to every student during the exam.
Yeah.
Right? So there's no need to print it out or bring your own.
Right. It's just like the midterm, right? We provided you with the same sheet that you saw on Piazza earlier. We'll do the same thing. It'll just be 2 sheets. Your exam will look just like the midterm. It'll just have more questions. How many questions we'll talk about on Monday. Okay? Nitty-gritty details about final exams. Any questions? If you have DSP accommodations, I've started to send those emails. You will get your email. If you haven't got your email by this afternoon, please get in touch with me to ask what's going on. Questions? Okay. So now, for better or for worse, it is important that you know how I see this course. And I see the course as 5 distinct chunks. One is, of course, Python, the language. The second is descriptions of data. And then there are some general concepts of inference that occur throughout. And then there is the theory of probability and statistics. And then there is details using all of this to do inference. I see these 5 chunks. And what I'd like to do is introduce you to the first 3 chunks rather rapidly. The last 2 are the ones where the bulk of the work gets done. And that is what I'm going to spend Monday and Wednesday doing. So for Python, you have to know how to compute. You have to know how to work with it. And that page was my attempt to summarize where it is in the textbook. The bulk of it is in chapters 3 through the early part of chapter 8. So that's about 5-ish chapters worth. 15.3 is where, right at the end of the course, when we were doing classifications, we finally told you about rows of tables. We could have told you earlier, and we probably should have. But anyway, we left it till when we got to classification. So that's where you have most of it. So most of it is here, chapter 3 through the early part of 8. Then there are some little functions that turn up and are used in various places, and I've tried to list as many of them as I could remember. I feel that I might have forgotten 1 or 2, so I've left myself a little room to adjust this slide if I have to. The GSIs are here. You guys, do you remember anything? Well, anyway, so if I think of something more, I will remind you of it. Proportions from distribution, percentile, and minimize are part of the data science package. And the others are part of just the various NumPy or SciPy and so on. I'm not going to talk in detail about them today. Some of the review sessions will go through code, but that's where all the stuff is to the best of my knowledge. Okay, so that's Python. Describing data, no inference. No inference, just I've got a data set. Can I say something sensible in a summary? And we don't think of tables as summaries, but they really are. They are a clean way of looking at a data set. So the first thing is tables, and the second thing is that you can use tables to further summarize by counting how many there are in various categories. You can classify, group, pivot, etc., creating proportions in different categories. That is a very important way of describing data. And so that's where those are. And then you get to drawing pictures. And the crucial thing that you draw a picture of is a distribution. And so there are pictures of distributions, visualizations. This one, it's all in chapter 6 mostly. 7.5 is maps. Okay, and then you have center and spread, and so averages, SDs, and correlation regression, right? But no inference yet. Just, here's a scatter diagram. What's the best curve I can put through this? Just that. That's what that is. And then, when we get to inference, there's language that we use. And that language is introduced throughout the textbook and just keeps getting used. None of it's very hard. But it's things like what's a treatment, what's a control, what's an empirical distribution, and so on and so forth. And that's where all of that is. Yes? So I think of these 3 as the fundamental building blocks of the computations and the inference that you do. After that, of course, there is actually the detailed work of answering questions to do with data, and that has to do with how probabilities and estimates behave, and what questions are asked, and that's the inference and that's the math of probability and statistics, and that is what I'm going to spend Monday and Wednesday doing. Does that sound good to you? So if you're going to do anything over this weekend, you might have a go at taking a look at your course in this sequence. Rather than starting from chapter 1 and going up to chapter 17, just take one of these chunks, right, and just go through that sequence. This last chunk is a good one to start with because I think it's easy, right? It will go fast. There's a lot of terminology and you'll go, yeah, I know this. Done. Finished.